The first objective that we're going to look at is determining whether or not a point is a solution to a system of linear equations. So what does that mean? We have previously talked about lines. For example, we know that that is an equation of a line. We've talked about how we can graph that. We can write that in different forms. But in this case, we are starting off with two lines. And what we want to know is, does this point satisfy both of those lines? Is this point a point on both of those lines? So the first thing I'm going to do is I'm first just going to graph these lines, and then we'll take a look at what's going on to see whether or not it is a solution. So to start, I'm going to graph the first line, the 2x plus 6y is equal to 24, and I'm going to graph that by finding the intercepts. If I was finding the x-intercept first, I would set y equal to 0. So I'm going to set y equal to 0, so I have 2x plus 6 times 0 is equal to 24. So that just says 2x equals 24, which tells me that x is equal to 12. So I know that the first line has an x-intercept at 12, 0. Now I'm going to find the y-intercept for that line. I'll find the y-intercept by setting x equal to 0 and solving for y. So I will plug in 0 for x. So I have 6y is equal to 24, and then I'll divide both sides by 6 to see that y is equal to 4. So I know that the first line also has a y-intercept at the point 0, 4. Now I'm going to do a very similar thing. I'm just going to shrink this down to find the x and the y-intercepts for the second line. I'll start off by setting x equal to 0, looking for the y-intercept. So I would just have 5y is equal to 3. Then I'll divide both sides by 5 to get that y is equal to 3/5. So I know that I guess I started off finding the y-intercept. I think I said the x-intercept. But I know that the y-intercept is the point 0, 3/5. Now I will find the x-intercept by setting y equal to 0. So I have x plus 5 times 0 equals 3. And we just get that x is equal to 3. So I know the x-intercept for the second line is the point 3, 0. So now let us plot these points. I'm just going to go by ones on both of my axes. For the first line, 12, 0 isn't going to fit on this because I think this only goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It only goes up to 10. So technically 12, 0 is like somewhere over here on the x-axis. And then my y-intercept is the point 0, 4. So I'll go up 4. And now I'll just attempt to connect these points. So the first line looks something like this. I'm also going to take this opportunity to go ahead and label my x and my y axes. Your axes should always be labeled when you're graphing. Now I'm going to plot the points on the second line. So we have an x-intercept of 3, 0. So here's the point 3, 0. And then we have a y-intercept at 3/5. 3/5 is a little bit bigger than a half. That's just about right there. So this purple line looks something like that. Okay. Those lines may look parallel, but they are in fact not parallel. And we know that we can find that quickly by determining the slopes of those two lines. Okay. So now let's actually see whether or not negative 3, 5 is a solution to this system, right? We haven't talked about that yet. All we've done so far is we've graphed these lines. To see whether or not negative 3, 5 is a solution, I'm going to plug that point in to both of the lines. And if it satisfies both equations, then it will be a solution. Hopefully, just from looking at the graph, you might have an idea of what's going to be happening. So when I take the point negative 3, 5 and I plug it into the first equation, we get 2 times negative 3, replace x with negative 3, and replace the y with 5. And we want to see what this equals. 2 times negative 3 is negative 6, plus 30, which is a positive 24, which is what we want it to equal. So negative 3, 5 is a solution to the first line. In fact, I can see it right there. The first line does go through the point negative 3, 5. Hopefully you can also see that that second line does not look like it's going to be going through the point negative 3, 5. If we plug negative 3, 5 into the second line, replace x with negative 3, replace y with 5, negative 3 plus 25 is not 3, right? The line says that it would be equal to 3 if it were a point on that line. So this ordered pair is not a solution to the system. In order for it to be a solution to the system, it would have had to satisfy both of the lines, and it only satisfied one of the lines. Now let's go take a look at example 2. I'm first going to quickly write what our intercepts are. That's going to help us graph the line. For the first line, to find the y-intercept, if x is 0, then y would be equal to a half. So this has the point 0, 1 half. And I know I didn't write a bunch of work out, but you can go off to the side, set x equal to 0 in the first equation. This is how you find the y-intercept. You get 10y is equal to 5, divide both sides by 10, and you get y is equal to a half. Now to find the now to find the x-intercept, if y is equal to 0, then x is equal to 1. So this is the 0.10. So what I said is to find the x-intercept, we set y equal to 0. If I take this equation and I set y equal to 0, that whole term is gone. I get 5x equals 5, and I divide both sides of the equation to get the x is equal to 1. In the second equation, let's go in and find the y-intercept first. So I'm going to first set x equal to 0. So this one's completely gone. I'll come in and I will divide both sides of this equation by negative 6. So I see that y is equal to a positive 1 half. So the second line has a y-intercept of 0, 1 half. Hopefully already you're noticing something. Let's go find what the x-intercept is for that second line, and I'm going to find the x-intercept by setting y equal to 0. So if I set y equal to 0, I'm going to have 22x minus 6 times 0 is equal to negative 3. That completely goes away. 22x equal to negative 3. X is equal to negative 3 over 22, excuse me. I'm just going to punch that in my calculator. It's a very small number. Well, not very small, but it's about negative 0.14, just to help us graph it, okay? So now I'm going to plot these intercepts. I'm going to plot the intercept of 0, 1 half for the first line. That's the y-intercept. And I'm going to plot the x-intercept of negative 0.140 for the... These are 2 points that are on the second line. We're going to plot those so we can see what the line looks like. Let's make this I'm going to adjust my scale. I'm just going to say that this is 1, this is 1, this is negative 1, and that this is negative 1. Okay, so now the point 0, 1 half is here. That's the y-intercept. And then the point negative 0.140 is about right there. So the first line, well, no, really the second line. The second line looks like this. The first line has a y-intercept, again, at 0, 1 half, right there. And it has an x-intercept at 1, 0, right here. So the first line looks like this. And we can see from the graph that the point 0, 1 half goes through both of those lines. We also knew it when we did our y-intercepts. And so, yes, 0, 1 half is a solution to the system. And it's a solution to the system because it satisfies both of the equations. And we don't really have to go in and plug in 0 and plug in 1 half. We already know it's true. We've already done the work when we found our y-intercepts to see that 0, 1 half is a point that is on both of those lines.